Good day. I am Mr. Salter, and we're going to be doing the test review for test 3 for College Algebra, Mac 1105. Just want to get started. For each pair of functions f and g below, find f of g of x and g of f of x. Then determine whether f and g are inverses of each other. Simplify your answers as much as possible. All right, so we're going to do the red problem first. So I want to find f of g, oops, of x. So the outside function is my f function, so I'm going to start there. It's 3 times some quantity x plus 2. And I put the parentheses because that's my outside function, and I need to put the inside function where the variable was. In this case, my inside function is g, which says x minus 2 over 3. All right. I can do some simplification here. To get rid of these parentheses, I can go on and multiply. Um, but I can also simplify. I have two threes here. So those would actually cancel out, leaving me with x minus 2 plus 2. And I have a minus 2 and a plus 2, so my answer here is just going to be x. Now I'm going to go over and do the other problem. Um, or not even, I'm going to do the g of f of x. So g of f of x is the same thing backwards. So my outside function is g, so it's going to be some value x minus 2 divided by 3. And that value is going to be my f of x function, which was 3x minus 2. Well, I have, or sorry, 3x plus 2. I have plus 2 and minus 2 on the top, so I'm simplifying that down to just 3x. I have a 3 on top and bottom. Those can cancel, leave me with x. When I did g of f of x and f of g of x, I ended up with not only the same answer, but I ended up with them both being the variable x, which means that these are inverses of each other. But it's because I got an x and an x. Can't just be two similar answers, has to both exactly be x. Doing the second problem, I have f of x is negative 5x. So to find f of g of x, I'm going to do my outside function, which is negative 5 times x. And my input function this time is the g, which is negative 5x. Doing some simplification, negative 5 times negative 5 is a positive 25. I can't simplify that any further, so I'm going to try the other one. This time I'm going to do g of f of x. So g of f of x. My outside function is the g function, which is negative 5 times some value. My inner function is going to be f of x, which is negative 5 times x. Simplifying, I get positive 25x. Notice here that they are both the same value, but those values are 25x, not just x. So these two are not inverses. Okay, they have to be equal and equal to x. All right. Fill in the missing values to make the equations true. Log base 6 of 13 minus log base 6 of 9 equals log base 6 of what? Well, according to my quotient rule of logarithms, whenever I have the exact same base being subtracted, I can rewrite it as log of that base, which is 6. And then the arguments from those two, the things in the parentheses, it's going to be the first one, but not minus. Instead, we're going to be dividing by the second. So the first argument divided by the second. 13 over 9 does not simplify. 13 is a prime number, so I'm going to leave it exactly like that. Next one, log base 5 of 12 plus log base 5 of something equals log base 5 of 48. So I have another rule of logs that says when my bases are the same and they're separated by addition, I can take the two arguments, in this case 12, and I don't know, so I'm just going to call it x. So 12 and x, and I can multiply them. So let's see how that would look. So I keep the base, log base 5, of my arguments multiplied. So 12 times my second argument, but I don't know what it is, so I'm gonna call it x. And I know that's equal to log base 5 of 48. Oops. Well, since the bases are the same and they're both a log equal to a log, that must mean that the arguments are the same. So 12x must equal 48. If I was to solve for x, I would divide by 12. 12s would cancel. 48 divided by 12 tells me that x is equal to 4. All right, the last one, log base 8 of 36 is equal to blank times log base 8 of 6. So my bases are the same. So I have a log where the bases are the same, but my arguments are different. How are they equal if my arguments are different? Well, I have this thing out front. I know that because of my exponential logarithmic rule, that the number out front used to be the exponent on the argument. So I could rewrite this as log base 8 of 6 raised to some power. I don't know what it is, so I'm gonna call it x. On the other side, again, I have log base 8. That is the same. What argument can I make to where 36 is equal to 6 to some power? Well, I know I could break 36 up. 36 is the same thing as saying 6 squared. So if 6 squared is equal to 6 to the x, that must mean that the exponents are equal. So x is equal to 2. This should be a 2. Suppose that the dollar value, V of t, of a certain house that is blank years old. Usually t tells me time. It's a bit of oversight. So t years old is given by the following exponential function. V of t equals 415,000 times 0.82 raised to the t. I want to find the initial value of the house. All right. Um, Doing exponentials, most exponentials come in the form of a times b to the t value, where t is my time in years, a is my initial value, and then b represents my change. So it's whatever, it's 1 plus or minus my percent of change. Just to kind of define function. So to find the initial value is this number out front. The initial value of the house is $415,000. Does the function represent growth or decay? Well, we talked about percent change a second ago. Growth is when it's going above 1 or 100%, and decay is when it is less than 1 or less than 100%. My number I have here for B is 0.82. That is less than 1, so that represents decay. By what percent does the value of the house change each year? Well, it says 0.82. How do I get 0.82 if I had 1 plus or minus some number? Well, because my number is less than 1, I know I'm probably going to be subtracting. So 1 minus something equals 0.82. How can I find that? Well, I can solve for x. Subtract 1 on both sides, in which case I get negative x is equal to 0.82 minus 1. You plug it into a calculator, you'll get negative 0.18. Divide both sides by a negative, and I end up with x is equal to 0.18. That's a decimal answer. They asked me what percent does the value change? 0.18 is the same thing as 18%. Okay. Solve for x. Okay, well, my x is nested inside my argument. So what I'm going to do is I'm going to change this logarithm into exponential form. So it's log base 7. So my base stays the base. My answer becomes my exponent. And my argument becomes my new answer. Well, 7 to the 1 power is just 7. So I really just got to solve for x. So first, I'm going to add 8 to both sides. Over here, it cancels. And on the left, I get 7 plus 8 is 15. Divide both sides by 5. And I get x is equal to 3. Solve for x. X is equal to 3. How much should be invested now at an interest rate of 8% per year, compounded continuously to have 2,000 in 4 years? So my general equation looks like this. It's my PERT equation. Ooh, let's try that again. It's very important that I write it correctly. Um, my R and my T are exponents. I want to make sure that that's clearly identifiable. So P times E raised to the RT, where P is my principal, R is my percentage expressed as a decimal, and T is my time in years. And A is how much money I'm gonna have after everything is over. So, given the information they gave me, they said 8% per year. So first I need to change this to a decimal. 8% is 8 divided by 100, which is 0.08. My time in years is 4. And I want to have $2,000, which means I don't have it now. So that's going to be my A value. So I'm plugging everything I know. I know 2,000 is my A value. I don't know how much I'm investing, my principal amount. I don't know. E is a constant, so I could just write the letter E. My rate, we already said, was 0.08, and my timing years is 4. Okay, well, I can multiply this right here. 4 times 0.08 is 0.32. I need to solve for P. Well, P is being multiplied times this e to the exponent. So to get rid of that, I'm just going to divide both sides by e to that exact same exponent. On the right side, it'll cancel, leaving P. What I do on one side, I do on the other. So I'm going to divide this by e to the 0.32. And that's a calculator function. So I have a Desmos calculator up. Uh, Most teachers allow a TI of some version. I would absolutely recommend that you make sure to have that ready, batteries, everything, because for this logarithms unit, you're going to need it. All right, so my p-value in my calculator comes up to 1452.298 dot dot dot. I'm talking about money though, so I always want to round it to my hundredths place. So I look at my hundredths place, it's a 9. The number to the right is an 8, which means I need to round up. So this 29 cents becomes $1,452.30. That is how much I should invest to have $2,000 in 4 years. Okay. Solve for X. Okay. Because X is in the exponent, I'm going to use logarithms to bring that down. So I'm going to change this into a log. It'll be log base 4 of my answer, which was 8, is equal to X plus 5. I'm trying to solve for X here, so I just need to subtract 5. But what I do on one side, I do on the other. Please do not try to subtract the 5 from the 8. A logarithm, the numbers are kind of locked into place, and that -5 just kind of comes outside. Okay. When we get to this part right here, again, calculator, make sure that you have access to a calculator. Um, Desmos, I think, is one of the best for doing things such as logarithms. But if you're going to use a TI, just make sure you understand how to plug them in appropriately. All right, so log base 4 of 8 minus 5 is equal to -3.5. This will be my answer. Suppose that the velocity v of t in meters per second of a skydiver falling near the Earth's surface is given by the following exponential function, where t is the time after diving measured in seconds. Okay, so he gave us the equation. V of t is 51 minus 51e should have been raised to the -0.022t. All right, cool. After how many seconds of diving, how many seconds after diving will the skydiver's velocity be 40 meters per second? So they said the velocity is going to be 40. Velocity is v of t. So I'm just going to be replacing that with 40 and then solving to find out how many seconds, which is time, I have. So I'm plugging in for v to solve for t. So 40 is equal to 51 minus 51e to the -0.022t. I want to solve for t. All right. First, I'm going to get rid of this 51. This leaves me with -11 equals -51e to the -0.022t. I want to get rid of the coefficient, the number out front. So I'm going to divide by -51. That gives me e to this long decimal t. And what I do on one side, I do on the other. 11 and 51, they don't simplify, but the negatives can cancel, so I get 11 over 51. I need to get rid of this e next. So what I'm going to do is I'm going to take the ln of both sides. And when I do, on the left, it's just going to be ln of 11 over 51. The ln and the e cancel, so that just leaves me with what was in the exponent, which is -0.022t. Last step, because I'm solving for t, is I'm going to divide by this decimal. And what I do on one side, I do on the other. Again, making sure that we have our calculator and we're familiar with how to use it will be a game changer for this test here. So the ln of 11 over 51 divided by -0.022 equals 69.7241 ... But it says round to the nearest tenth. This is my tenths place. The number to the right is a 2. So my answer is just going to be 69.7 seconds. A lot of work, but it was really just order of operations ramped up with our understanding of logs is really what it was. Below is the graph of y equals ln of x. Translate it to become y equals ln of x plus 2 plus 5. All right. So they told me what I was going to be doing. I'm doing a translation, not a reflection or a rotation. Translate means I'm sliding. And the things that tell me what to do are the things that are being added or subtracted. I have one thing inside the parentheses, one thing outside the parentheses. Inside the parentheses always tells me if I'm going to be moving it left or right. This plus 2, although normally plus 2 means go into the positive direction, for translations, that's telling me that I need to go to the left 2 units. This plus 5 on the outside or outside the parentheses always refers to the up and down movement. Plus 5 means I'm going to be going up 5 units. So what I'm going to do is I'm going to take a couple of points from the graph that are very clear and easy to identify, and I'm going to move them 2 units to the left and 5 units up is going to be my goal. My graph, unfortunately, looks like it kind of cuts off before I get to 5. So this will be a little unique, but that's what I'm doing. So I'm going to find a couple of points, and I want some that are like right on the crosshairs. So let me change my color so we can see it. How about a nice green? So I see some on a crosshair. Let's see, right here. And then another good one might be, oh, here's one right here on the axis. Boom. All right, to the left 2, up 5. So with this one I just did, that's roughly at the point 1. See, it's halfway between 0 and 2. So it's at 1, and I want to go to the left 2 units. So 1, 2 units will bring me here to -1. But I also want that point to go up 5 units. So I go over 2 units, and I want to go up. Like I said, it kind of cuts off a little early, but 5 units will probably be about right here. All right. And I want to do the same thing here with the second point. So go to the left 2 units. So we're at 1 before 8. So I'm going to go 1 before 6. That'll be 2 units. And then I want to go up 5 units. Again, I kind of ran out of room. My 5 units probably be about what, right here maybe? So this would be something like this. Something like that. Take a couple of points, shift it the way that it's asking you to shift it, and then connect the dots. I couldn't pick one that was here because if we remember our lessons, both ln or natural log functions and the e functions, my exponentials, have asymptotes, which means it gets close to a line but never hits it. So this one here, since it's at 0, if I was to go over 2 units, it will probably actually have an asymptote probably at about 2, so probably like right here. So something probably a little closer to that. Connect my dots again. That's probably more or less what it'll kind of look like. Okay. All right. Evaluate each expression. Log base 8 of 1/8. Well, this argument, I can rewrite that. Um, log base 8 of, I could call that 8 to the negative first power, because a negative exponent makes you do the reciprocal. But I know that when I have an exponent, I can move the exponent out front. So this could also equal -1 of log base 8 of 8. And whenever my argument and my base are the same number, that means that the whole log is equal to 1. So this is really -1 times 1, which is -1. Log base 8 of 1/8 is equal to -1. Log of 1,000. Well, log of 1,000 is just like saying log base 10 of 1,000. All right, I don't know what that equals. I could rewrite this as an exponential. It'll be 10 to the x equals 1,000. So 10 to what number equals 1,000? Well, 10 is one of my special numbers. And the way it works with exponents is the exponent just tells me how many zeros are on it. So if the number was 1, I'd have 10 to the first, which is 10. If my exponent was 2, I'd have 10 to the second, which equals 100, or 2 zeros. So the number that this is equal to is 10 to the third is equal to 1,000. So in this case, my answer is equal to 3, 10 to the third power. Suppose that 5,000 invested at an interest rate of 2.5% per year, compounded continuously. The word continuously is my math action word. It tells me that I need to use E. So my equation is going to be another A equals P E R T. The question is, after how many years will the initial investment be doubled? Okay, well, my initial investment is 5,000. My p-value is 5,000. E is a constant. My interest rate is 2.5%. Please don't put in 2.5. 2.5%. I have to move my decimal 2 places to the left. And in that gap, I put a 0. So my R value is really going to be 0.025. Make sure to change percents to decimals, even if they have a decimal point in them already. And then my T value, it says after how many years? That how many tells me I don't know. So that's just going to stay a T. After how many years will my investment, my $5,000, double? Double. So I want to know, when will 5,000 double? Okay. I'm solving for T. Well, the first thing I'm going to do to get T by itself is I'm going to get rid of the coefficient. I want to divide both sides by 5,000. On the right side, it cancels, leaving E to the 0.025 times T. And on the left side, it also cancels, leaving me with 2. All right. Next, I need to get rid of the E, so I'm going to take the ln of both sides. On the left, I end up with ln of 2. And on the right, ln and E cancel out, leaving me with 0.025 T. Last step to get T by itself, I'm going to divide both sides by 0.025. On the right side, I get some cancellation, so I get a T. And on the left side, ln of 2 divided by 0.025 is equal to 27.7258. Round your answer to the nearest hundredth. This is my hundredths. The number to the right is a 5, so it's going to round up to 27.73. So after how many years will my investment be doubled? About 27 years. Certain loan program offers an interest rate of 7.5% per year, compounded continuously. Assuming no payments are made, how much will be owed after 4 years on a loan of $3,500? Same thing, different numbers. So A equals P E because it said continuously to the RT. All right. So the principal, the original amount of this loan is 3,500. E is a constant. My interest rate is 7.5%. I need to change that into a decimal. So I move it two places to the left, and in the gap I put a zero. So my interest rate is 0.075. My time in years is 4 years, and I'm not sure what that's going to equal, so it's just going to remain A. All right. Everything on the right, I know we have a letter E, but technically that's not a variable, that's a constant. I can plug this directly into my calculator or, again, Desmos, and be able to get an answer for this. So 3,500 times E to the 0.075 times 4 gives me 4,724.5058. And it says round to the nearest cent. Cent just means hundredths, right? There's 100 pennies in a dollar. So I'm going for my hundredths, which is here. The number to the right is a 5, so that means it's going to round up. So my answer is $4,724.51. That's how much you will owe on this loan of $3,500 after 4 years. Rewrite as an exponential equation. Okay, so I'm changing a log to an exponent. My base, which is 3, stays at the base. My answer becomes my exponent, and my argument becomes my answer. Rewrite as a logarithmic equation. Okay, 7 to the second power, so 7 stays my base. So log base 7. And then I switch places with the other two. 49 moves to the left, and the 2 moves to the right. All righty. Solve for x. So log base 3 of x plus 3 equals negative log base 3 of x plus 5 plus 1. I have log base 3 and log base 3. I'm going to move them on the same side. So I'm going to add log base 3 of x plus 5 on both sides. On the right-hand side, it cancels out, leaving 1. On the left, I have log base 3 of x plus 3 plus log base 3 of x plus 5. My bases are the same, and I'm adding, which means that I can combine it into a single logarithm of that base, but the argument's being multiplied. So x plus 3 times x plus 5. I'm going to go on and change this into an exponential. That way I can actually solve for this x. So my base is 3, so it's going to be 3 to the 1 power is equal to x plus 3, x plus 5. I'm going to go on and FOIL that right-hand side. 3 to the 1 power is just 3. So I end up with 3 equals, if I FOIL it, I get x squared plus 3x plus 5x plus 15. Combine like terms. 8x plus 15 Um, I want to go on because this is a quadratic and I'm gonna move my 3 to the other side. So I get 0 equals x squared plus 8x plus 12. All right. Looking at it, I can go a few different ways with this. If you're familiar with it, feel free to use the quadratic or you can factor. We've learned a lot of different methodologies for solving quadratics or parabolas of this form. I'm gonna go on and just factor. It's the one I'm most comfortable with. I know that I can factor this up into x plus 2, x plus 6, because 2 times 6 is 12, 2 plus 6 is 8. Set both of these equal to 0, and I get x equals -2 and x equals -6. Because I'm dealing with logarithms, I have to try these both into my log functions to see if they work. Because remember, logarithms do not exist when the argument is less than or equal to 0. So I need a positive answer. So I'm going to plug these in. If I plug in -2 into these, I end up with -2 plus 3, which is 1, and -2 plus 5, which is 3. This works out perfect. Now I'm going to try -6. If I plug a -6 in, I'm going to do it on the right. I get -6 plus 3 and -6 plus 5. -6 plus 3 is -3. -6 plus 5 is -1. I can't have negative arguments, so this answer does not work. The only one that works here is x equals -2. So what's my solve for x? X is equal to -2. A lot of work, but it's all stuff we're familiar with. State whether it's one-to-one. To determine if something is a function, we do vertical line test. To determine if it's one-on-one, one-to-one, we do a horizontal line test. So looking at my graph one, are any of these on the same horizontal line as each other? No, 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 no. Is this one-to-one? Yep, it passes the horizontal line test. The next one, if I was to do horizontal lines anywhere on here, it would hit once and only once each time. This passes. Here, it hits only one time. Perfect. Down here, if I hit it at just the vertex, it'll hit once, but everywhere else, it's hitting twice. This is not one-to-one. Here, the first one looks good, second one looks good, third one looks good. These two are on the same line. This does not pass. Here, yeah, again, right across this little mountainous area. And depending on where you hit it, you might even be able to catch it like 4 times. So this is totally not it. For the one-to-one function, find the inverse and state the domain and range of the inverse. So to find the inverse, I change places with my x and y. G of x is my y. So when I switch places, I end up with x is equal to 3y over y minus 6. And now I want to solve for y. All right. First thing I'm going to do, because I don't want to deal with this fraction, I'm going to multiply both sides by y minus 6. On the right side, it cancels out, leaving 3y. And over here, I could do some distributive. I end up with xy minus 6y. Or, sorry, minus 6x. All right, now I want all my y's together because I'm solving for y. Um, I'm gonna go on and just move this one over. So I have negative 6x equals 3y minus xy. I'm going to factor the y's. Do I have 3 minus x? Last step, I want to get y by itself, so I'm going to divide both sides by this parentheses of 3 minus x. And on the right side, it cancels, so I'm left with y is equal to negative 6x over 3 minus x. All right, so what would the domain of something like this look like? What would the domain of it look like? Well, the domain, because this is a fraction, is based on the denominator. My domain could be everywhere except where the denominator is equal to 0. Where is this equal to 0 at? Well, whenever x is equal to 3. So my domain will be everywhere except that one point. So my domain will be from negative infinity to this point, but not actually touching that point and then going all the way to positive infinity. Okay. What would my range look like? What would my range look like? Well, what would the parent function of this particular thing look like? Well, negative 6x over 3 minus x. If I was to graph it, will probably look something like this, similar to my 1 over x, which is essentially the parent function here. So what would my range be? My range theoretically should be from negative infinity all the way up to positive infinity, but somewhere in there, I'm going to have an asymptote. I'm going to have something that doesn't actually work. And in this case, my asymptote is whatever I get when I take these numbers over each other. 6 over 3 is 2. So my range is negative infinity to 2, and then again from 2 to positive infinity. I think we have another one in here where we're going to look a little further into asymptotes, so I'm going to wait for that one. Graph 3 to the x power minus 1. 3 to the x power minus 1. All right, well, this is an exponential. So generally speaking, my exponentials kind of start off at my x-axis and usually hit up at about 1 and kind of keep going, is what my general form looks like. For this one, I'm going to change color so we can see it a little bit better. For this one, I have a negative 1 outside. That negative 1 is telling me to translate down 1 unit. So instead of having an asymptote at the axis, it's going to have an asymptote at 1 unit below that. So right about here. And instead of hitting at 1, it's probably going to hit at 0. So something kind of like this. So plot 2 points and draw the asymptote. All right. Well, my function, I'm going to do a t-table for this one. 3 to the x minus 1. I want to plug in numbers that are easy for me to use exponents on. So I'm going to try the number 0 because it only need 2 points and 1. So I have 3 to the 0 power minus 1. Well, 3 to the 0 is 1. 1 minus 1, 0. If I plugged in a 1, I get 3 to the 1 power minus 1. 3 to the 1 is 3. 3 minus 1 is 2. So 2 points on this will be at 0, 0, which I already have right here in my origin. And then 1 comma 2, 1 comma 2. Oh, okay, looks like I needed to have come up a little bit more. So this is going to be more like this. See if I can erase that so we can get a clearer picture. All right. There we go. Give the domain and the range in interval notation. My domain is how far left to right it goes. In this case, my domain is going to go from negative infinity to positive infinity. I have no breaks, no asymptotes, no nothing. My range, how far down and up is it going to go? Well, the lowest point it's going to have is going to be right at my asymptote, but never touching it. So from -1 all the way up to positive infinity. Below is the graph y equals 1/4 raised to the x. Translate it to 1/4 raised to the x minus 2 plus 3. So this plus 3 on the back of it tells me I need to go up 3. This minus 2 attached to the x tells me I'm going to be going to the right 2 units. Remember, with x's, it's always in the reverse of what we normally think. So I'm going to pick a couple of points. And I'm going to move them to the right 2 and up 3. So where's a good point? I want to find something at a crosshair. So maybe this one and this one. So I want to go to the right 2 units. Please note that the long ones are at 2. So I'm going to go over to here, do my squiggle, over 2 units, and I want to go up 3 units. Um, well, this is a dash above 0, so I want to go a dash above 3. If this is 3 right here, I'm going to go up to a dash above that. This will be that new point. And then this next one, same thing. I'm going to go over 2 units. And then I want to go up 3 units. This is at 1, so I need to go up to 4. And my asymptote was down here at 0. But since I go up 3, it's now going to be up at 3. It's going to be my asymptote now. So when I connect the dots, I get something like this. Okay. And then, of course, it'd be going up some more. We just ran out of room. All right. All right. Solve for x and round to the nearest hundredth. Okay. A couple of ways I could do this. I'm gonna show 2 ways actually. Leaving it as an exponent, because this also can be a base 2. I can change 16 to 2 to the 4th power. And if I did, my exponent rule of powers tells me I multiply these two to where I get 2 to the 12x, and of course is equal to 2. Well, 2 is the same thing as saying 2 to the 1st power. So if my base is the same, I just compare my exponents. I have 12x is equal to 1. So x must be 1/12. But it said round to the nearest hundredth. So it sounds like they want me to have a decimal answer. Let me try doing it my other way. Other way I would have done it is I would have changed this exponential into a logarithm. It'd have been log base 16 of 2 is equal to 3x. And then I could just divide both sides by 3. Um, this log base 16 of 2x is absolutely a calculator function. And if I was to do it and put it in the calculator, I'd end up getting 0.083333, repeating. Round to the nearest hundredths. This is my hundredths place. So my x is going to be 0.08. The 3 tells me it stays the same. Okay. Find the inverse and domain and range of the inverse. Okay. Well, one, I'm gonna change my color. We've been doing the same color for a second. Let's do purple. So f of x is my y. To find the inverse, I switch places with x and y. So x is equal to the square root of 2 minus y plus 5. To solve for y, first I'm going to get rid of this plus 5 by doing a minus 5. I end up with x minus 5 is equal to square root of 2 minus y. I need to get these things from under the radical, so I'm going to square both sides. Um, on the left-hand side, I'll end up with x squared minus 10x plus 25. The shorthand way of squaring this out is you square the first term. The first term times the second term times 2 gives you the middle. And then you square the last term. -5 squared is positive 25. Just a little trick. And then square and square root cancel out, leaving 2 minus y. Alrighty. To get y by itself, I'm going to subtract 2. I end up getting -y is equal to x squared minus 10x plus 23. And then this is a negative, so I'm going to divide to get rid of this negative, make it a positive y equals. And then this negative essentially just gets distributed over. So it's -x squared plus 10x minus 23. It just changes the signs on everything. Find the inverse. Check. This is my inverse. And the domain and range of the inverse. All right, this is a quadratic. And it's a negative quadratic at that, which means that on a graph, it's going to look something like this. So to find what my domain and range is, the domain of a quadratic is always -infinity to positive infinity or all real numbers. The range, well, my range goes from lowest to highest. In this case, it's going all the way down to -infinity. So that's where I'm going to start with my range. And it's going to go up to the highest point. What is the highest value that I'm going to have here? Well, the highest value of a parabola is the vertex, right? So the vertex is always stationed at x equals -b over 2a. In this case, that'll be -20 over 2 times -1. The negatives cancel out. 20 divided by 2 is 10. If I plug 10 into here, I should find out what my highest range value is. So I have negative of 10 squared plus 10 times a -10 minus 23. This gives me -100. It's 10 squared, then made negative. 10 times -10 is -100. So I end up with -223. Are we okay? All right. In 1998, a city had a population of 390,000 people. Each year since, the population has grown by 8.2%. Let T be the number of people since 1998. Let Y be the city's population. Write an exponential function showing the relationship between Y and T. So it said Y is going to be my population and it's going to be an exponential function, right? So A times some B to the T. A is my initial value, which I know to be 390,000 people. My B value is 1 plus or minus my percent change. Well, in this case, it's going to be plus because it says grown. So plus whatever my percent change is. My percent change is 8.2%, but I need that as a decimal. So I move the decimal point 2 places to the left and add a 0 in the gap. So it's going to be 0.082. And then raised to the t. Write an exponential showing the relationship between this. At most, I could simplify what's in my parentheses. So I get y equals 390,000 times 1.082 to the t. All right. Solve for y. All right, because y is in the exponent, I'm going to use a logarithm to get that out of there. Um, and because it's to the e, what I'm gonna do is I'm just gonna take the ln of both sides. So remember, ln is just the natural log as a form of the log. When I take the ln of e, the ln and the e cancel out, leaving y minus 4 equals the natural log of 8. I want to add 4 to both sides. I get y equals the natural log of 8 plus 4. It didn't tell me to round to a decimal, so technically this is the correct answer. I'm going to leave it like this for now. If it told me to make it a decimal or simplify my answer or something like that, I'd go further. It didn't, so technically this is correct. You can just plug it in a calculator if you want the direct answer. Graph g of x equals negative log 4x. Plot 2 points and give domain and range. Okay. It's asking for a lot, but it's not something that's out of our wheelhouse. It's definitely something that we could do. So I know that a normal logarithm on a graph looks something like this, right? Um, this is a negative log. I can imagine it's probably going to be flipped upside down. So maybe coming from the top, coming down somewhere is what I'm going to imagine it's going to look like. Um, please note that logarithms, because my argument can never be negative, have asymptotes. They stop at 0. Technically, my logarithm can't be 0 or less. So my asymptote's always going to be at 0. Um, plot 2 points and give domain and range. Okay, I'll come back to domain and range in a bit. For right now, though, I need to plot my 2 points. I'm gonna use a t-chart. X, and I'm gonna call my g of x my y. And for this t-chart, because I'm not really good at understanding logarithms as they are, I want to change this to an exponential. So I know that y is equal to negative log base 4 of x, right? This negative, I'm just going to divide by negatives and kind of switch it around. So if I was to divide by a negative, that negative essentially would just move to the other side. And now I'm going to make an exponential out of it. I'd have 4 to the negative y equals x. And that's what I'm going to use. Um, x equals 4 to the negative y, negative y. So what I'm going to do is I'm going to plug in y values to get an x. Well, I know the easiest thing to plug in will be 0, because then I would get 4 to the 0 power, which just equals 1. There's no such thing as negative 0, but it was there, so I put it there. I know if I plugged in a 1, I would get 4 to the negative 1 power, which negative 1, remember, that just makes it into a reciprocal, so that's 1/4. I don't know if I want to use that. I don't know how I feel about plotting a fraction. So I'm going to do the other way. What if a negative 1 was plugged in? Then I'd have 4 to the negative of negative 1, which is just a positive 1, which is 4. It said I needed 2 points. I'm going to use these 2 points to avoid the fractions. All right. So I have 1 point at 1 comma 0. So 1 is here, comma 0 will be right there. And then the next point I have is at 4, negative 1. 4, negative 1 should be about here. And I know that at 0 is an asymptote, so it can get close but never really touch. So if I was to connect the dots, it would probably come up like that. And then here we'll connect the dots and keep going. So what's my domain and range? Domain is how far left to right. So my domain, it starts at my asymptote but never touches my asymptote, and it goes to infinity. My range, this is going to keep going downward, so it's going to go from negative infinity all the way up to positive infinity. We okay? Solve for x and round to the nearest hundredth. All right. Well, I have 3 times the natural log of 8x. First thing I'm going to do is I'm going to divide by 3. And I get ln of 8x equals negative 1. All right. I'm now going to, there's a couple ways to do this. Either way, it looks the same. I'm going to change this back to an exponential. When I change it back to exponential, this is really log base e. So it's going to become e to the negative 1 equals 8x. And then divide both sides by 8. So I get x equals e to the negative 1 over 8. I need to figure out what this equals. So I go back to my calculator and I do e to the negative 1 over 8 gives me 0.04598, but it said nearest hundredth. This is my hundredths. I look to the right. I have 5 or higher, so I'm gonna round up. So x equals 0.05. All right. Use change of base formula and round to the nearest thousandth. Change of base formula says that if I have a logarithm, I can do log of the argument over log of the base. It has the same valuation. Mm. Um, there's a couple ways I could do this. This 1/8 at the bottom, that's the same thing as saying 8 to the negative 1. And I have a rule about exponents. When I have a logarithm, I can move the exponent out front. So this is really log base 6 of negative 1 log of 8. I can plug that into a calculator straight away. And when I do, I end up getting, let's type it in, log of 6 over negative log of 8. Negative 0.8616. Round to the nearest thousandths, tenths, hundredths, thousandths. That's this one. I look to the right. I need to round up because that's 5 or higher. So my answer is negative 0.862. Okay. Rewrite each equation as requested. So I want to rewrite e to the 4 equals x as a log. So it'll be uh, log with a base of e of the x is equal to 4. But log base E is the same thing as saying ln of x equals 4. Rewrite as an exponential. Well, ln is log base E, so that's going to be e to the y is equal to 8. Certain forest covers an area of 5,200 square kilometers. Suppose that each year this area decreases by 8.5%. What will the area be after 7 years? All right. Um, this looks like another exponential. Remember, A represents my initial value, which in this case is 5,200. T is my time in years, which they already said was going to be 7. And my decrease is by 8.5%. 8.5% is 0.085. Remember, change it to a decimal, even if it has a decimal in it. And so it's going to be 1. The decreases means minus that percentage. If it said it was growing by that much, I would add. It's always 1 plus or minus my percent change. 1 minus 0.085 gives me, let me go to my calculator to make sure I don't make any mistakes. Please, let's not guess at this. Use your calculator whenever you have math to do. I know it sounds kind of ironic, but a lot of us like to do stuff quote unquote in our head, and that's not always the best place to do math. All right. And I can just go on and plug this into my calculator as well. And I get 5,200 times 0.915. Let's try this again. 5,200 times 0.915 raised to the 7th power equals this. Round to the nearest square kilometer. When they just give you your units as the thing, they mean whole number. So I look at the number to the right, it's a 2, so my answer is simply going to be 2792. So if a forest is 5,200 kilometers and each year it decreases by 8.5%, after 7 years, it's going to be down. It's almost half. It's half. All right. Find the inverse. All right. I'm just gonna call this variable here t is equal to this. To find the inverse, I switch places and solve for it again. So I'm gonna get h is equal to 90 minus 2.5t, and then solve for t. So minus 90 on both sides. I get h minus 90 equals negative 2.5t. Divide by negative 2.5. And I get t is equal to h minus 90 over negative 2.5. This is my inverse. Rewrite this as a single logarithm. Okay, the only reason that's possible is because they all have the same base. They all have the same base. A couple of these have numbers in front, which will become exponents. I'm going to do that first. So this becomes the exponent of z, and this becomes the exponent of y. So I have log base 6 of z to the 5th minus, oh, and I have one here. Almost didn't even notice it. Minus log base 6 of w to the 1/4 plus log base 6 of y to the 3rd. All right. My minus means that I'm dividing, whereas my plus means that I'm multiplying. Um, So this is going to be log base 6, because they all have the same base. I'm starting with z to the fifth. Oh, that's a little big. And I'm starting with z to the fifth, minusing w to the 1/4. That means divide. And then it's also being added to y to the third. That add means I need to treat it like multiplication. Expression as a single logarithm with a complicated argument. Use the property of logarithms to expand. So basically the same thing backwards. I'm expanding this time. First things first, I have something to the fifth. To the fifth is just like raising it to the 1/5. I'm gonna go on and distribute to each of these, and then I'll do my split up. Okay. So this is like log of x to the 2/5, y to the 4/5, z to the 3/5. Since these are all being multiplied times each other, I can split it up using my property of addition and say log of the first one plus log of the second one plus log of the last one. And now I'm going to do my rule of exponents says I can move my exponents out front. So what I'm really going to have is 2/5 log x plus 4/5 log y plus 3/5 log z. That is a fully expanded logarithmic expression. Write the domain in interval notation. We talked before, my argument, my thing in parentheses, has to be greater than 0. Not even equal to, just greater than 0. So where is 6 minus x greater than 0? Well, if I was to add x to both sides, I get 6 is greater than x, or x is less than 6, is my domain. So that's basically saying that my domain is any number from negative infinity all the way up until I get to 6. Because if I put a 6 in here, I get 6 minus 6 is 0, and that wouldn't work. And anything bigger than that would give me a negative number that also wouldn't work. So here's my domain. This is our last slide. I want to thank you all for watching. I'm Mr. Salter. I work in the Tallahassee State College Learning Commons. If you ever need help, support, advice, or assistance getting through any of your core classes, math, science, English, social studies, or even public speaking and civic literacy, please come over. We are on the south side of campus, across from Wendy's with the big pillars in front. We share a building with the library. Um, Look forward to seeing you. Thank you so much for joining us here today.